All right, good afternoon. I'm 12 here, 2 farmers. Hopefully others will get the recording. All right, so today we're gonna be doing really the last topic that we have left, which is statistics and probability theory. What I have on the screen here is a syllabus. Now, this is something that in the past, it was an optional question and exam paper that I would do with the kinematics, which is motion and straight line. And it was optional to do either the kinematics or the statistics. And so this is a topic that I would not have taught in the past. Right? But now it's compulsory. And so as you would see, I would have notes and slides and stuff for all the other topics. I don't have the notes and slides for this topic. So I'm going to teach this topic. I will do this topic by example. Easy topics there, right? That's some basic things, and the basically I have the same things every year. I'm going to do it by example. But this is what I have on the screen here is a syllabus in terms of what is it that you need to know, right? And you can maybe go and look up some of this information for yourself as well. But it's a distinguish between types of data. And some of this is stuff that you would have learned at CSEC as well. Qualitative and quantitative data. Discrete data, discrete and continuous data. Qualitative, quantitative. Quantitative is like measuring stuff. No, quantitative like counting stuff. Quantitative, you can quantify. Qualitative is like I say, how dark something is, or how bright something is, or how deep the color blue is. That's qualitative. How clean something is, how dirty something is. That's qualitative. And then we have discrete data. Discrete data is counting data. We have to count stuff. So 1, 2, 3, 5 boys, 10 girls. Things we have to count. And continuous data is things that you have to measure, like the height of something, the weight of something, the length of time something takes to happen, right? And the discrete data is precise values: 1, 2, 3, 4, 5, 10 trees, 5 cars, 11 cows. While continuous data is measurement. So somebody might be 1.53 meters tall. Not an exact value. It all depends on the level of accuracy. You might choose to put 1.5 meters instead. I might put 1.5321. Not exact values when it's continuous data. That is it in a nutshell. Some statistical diagrams that you will see here that we did not see in CSEC is what they call stem and leaf diagrams. Stem and leaf diagram. We're going to look at an example of that. Pretty straightforward, pretty easy. And then you also have one that they call a box and whisker plot. A box and whisker plot basically is showing the data spread out, and you have the quartiles, Q1, Q2, Q3. You have the lowest value and the highest value. And then we're going to talk about skewness. Can be right skewed, positively skewed, or negatively skewed and stuff. Generally speaking, in order to put a box in the quartiles. We're going to see examples with it as well. And then we have stem and leaf diagrams. Stem and leaf diagram is just another way of representing your data. That's a way of representing your data. We're going to see the examples of those. All right? We're just going to do some past questions and do examples of those. All right? Then you have this here now that says, outline the relative advantage of the stem and leaf diagram and the Boston whisker plot. You can look up these and see what are the advantages of them. I think it's just another way of representing the data. For example, the stem and leaf, what happens is that you use less figures. You don't have to be repeating. You don't have to be repeating some of the numbers. It's a more compact way of representing the data. That's a stem and leaf. The box and whisker plot, it allows you to sort of see how the data is spread out. or the data is skewed, if the data is symmetrical or not. So it gives a visual of the data, shows, and it basically breaks down the data into the quartiles. And you can see if it's skewed one way, skewed another way. You can see also if there are any outliers. We can look how we calculate outliers. All right. Here, I want us to interpret stem and leaf diagrams and box and whisker plots. In other words, they will give us these diagrams and we have to extract information from them. All right. We're going to see some examples with those. Determine quartiles and percentiles. We know the quartiles already, we learned those in CSEC. So you have Q1, Q2, Q3. Q1 happens to be the 25th percentile of the data. Represents the position of the 25th figure in the data when the data is in ascending order. It has to be in ascending order. And this one is the 50%, represent the 50 percentile, this one. 50 percentile, because it's right in the middle of the data. And then this one will be the 75th percentile. So you can see the relationship with the percentile. The percentile basically is if you divide the data into 100%. So for example, if you have 100 scores, if the data has 100 values in the data, and you put them in ascending order, then the 20th percentile, is just 20%, is the value in the 20th position. So you take 20% of the 100. It goes 200 pieces of data, 200 values, and you want the 20th percentile. After you put them in ascending order, 20% of 200 is 40. So it will be the 40th value in the data, will be the 20th percentile. Simple as that. 20th percentile. So you have quartiles, now they're introducing percentiles. And there's also another measurement that they call it deciles. Deciles, I think, is where you divide it into 10. Yeah, deciles were divided into 10 equal parts. So the first decile will be 1/10. Second decile will be 2/10. Third decile will be 3/10, and so on. But here we're just focusing on quartiles and percentiles. So we're going to see examples and we'll deal with them. All right, we'll deal with them when we get to those figures. So you have to find these values from our stem and leaf diagrams and also on the box and whisker plots. All right, calculate measures of central tendency. Those are the same things that we did in CSEC. Mean, mode, median. Mean, mode, median. See them here, mean, mode, median, range, interquartile range, that is CSEC. Semi-interquartile range, CSEC. What we did not get at CSEC were these two, variance and standard deviation. We did not get how to calculate those in CSEC. Now you have to calculate them in this level, but guess what? These can be calculated easily because this is a formula that you use to calculate them. So if you look at the formula sheet, it is there. Look at the formula sheet, it is there. So what's the relationship between the variance and the standard deviation? The variance, I'm just telling you right now, the variance is, the symbol for variance is S squared. And the symbol for the standard deviation is S. Standard deviation is S, you know. So what it means, therefore, is that the standard deviation is the square root of the variance. The square root of the variance, that is it. Standard deviation is the square root of the variance. So if you calculate the variance, you just square root the variance to get the standard deviation. This is the formula for calculating over here. I'll give you two formulae. I'm going to do some examples. This is the formula for calculating your variance. This is the variance formula. And to get the standard deviation, if I take off the square off of this, and square root this, I get the standard deviation. If I square root this, I get the standard deviation. All right? And I'm going to explain what all of this is when we start to do the examples. This is the difference between the values and the mean divided by the number of values. This means that they take the sum of that. We're going to do a table and show it. This is another formula that can be used to do it. This formula might be the easier one to use. But this is the sum of the square of the values divided by the number of values, and you subtract the square of the mean. So this formula is on the sheet for you to calculate your variance or your standard deviation. And then the variance and the standard deviation, as we said in CSEC, are the simple measures of how the data is spread out from the mean. So the higher the variance or the higher the standard deviation is, the more the data is spread out from the mean. Simple as that. The smaller the standard deviation or the smaller the variance value is, the closer the data is to the mean. We did this explanation in CSEC as well. Because in CSEC we had to interpret, we had to compare two sets of data. We had to compare the standard deviation of two sets of data. We learned that if the standard deviation is high, it simply means that the data has a wide spread from the mean. I will have to say from the mean. It's a measure of how the data is spread from the mean. And it's spread both sides, negative and positive from the mean. Right? So for example, if you have some values 4, 6, 8, 10, 12, as compared to some other values 2, 4, 6, let's just use 2, 5, 8, 2, 5, 8, but I'm adding 3, 11, and 3 more, 14. These two data have the same mean, you know. The mean for this one is 8 and the mean for this one is 8. They would have the same mean, value in the middle. If you were to calculate it, it's mean we want to know. It's mean we want. But I'm saying, let's say this is the mean. Right? Let's say this is the mean we want. The mean. Standard deviation is deviation from the mean, not the median. But let's say the mean is 8. That's for argument. Okay, maybe check it. If you add up these and divide by 1, 2, 3, 4, 5, I think it's gonna come to 8. Right? That's it's gonna come to. But don't worry about it. Let's say this is the mean. This one would have a smaller standard deviation because the value deviates between those 4 and 12 as compared to going between 2 and 14. This one is wider. The data varies wider than the one up here. This one is less wide or more narrow. All right? This have a lower. This would have a higher standard deviation. This is wider. What's opposite of wider? What's it? More narrow or less wide. Let's just write less wide. So this one up here would have a lower standard deviation than this one down here. That's all standard deviation is measured. How wide is the data spread away from the mean score? That's standard deviation. All right, and the CXC will ask you to explain and compare two standard deviation values. We're going to see them in some examples and we can answer them. All right, and that's what this one is saying. That's what this down here is saying. Down here saying that. Explain how standard deviation measures the spread of a set of data. Explain it. Measures how the data deviates from the mean. That's what it indicates. I also have to compare sets of data. Right? And that is the statistics. But the thing kind of moving slow. That is the statistics part of it. I'm going to do the probability part in another class. So I'm not going to bother talk about this part today. So what we're going to do today, we want to do the past paper questions. I want to do the standard, we want to do the statistics questions from the past papers. And I explain each thing as I go on. I just need to explain it once. I'll explain how you do this, how the stem and leaf is red, how you draw it. I'll explain the box and whisker plot. I'll explain if we get in a question with mean, mode, median, standard deviation, I'll calculate them. All right, that's all we have to do. Just some examples. I was going to jump to that. I'll deal with this part in another class, maybe the next class. The probability part of the syllabus. Up here, we're focusing on up here today. The statistics part of it. All right, focusing on that part of it, the statistics today. All right, so I'm going to jump to the past papers and not even hesitate. I'm going to jump to past papers. And I'm going to do the very last paper that was set. I was going to take the topics as they come. All right, we're just going to take them as they come. All right, we're just going to take them as they come. So this is the, remember, if you have to calculate standard deviation, you just come to the formula. Come to the formula right here. That's the formula. A more simplified way of writing the formula is to say the standard deviation would be, and I like to use this one. It becomes the square root. You don't put down about the square on this, the standard deviation. With the square, it's the variance. Right? It is the square root of the sum of x squared. I don't have to put the f. The only time the f comes in place when you have the same value repeated, divided by the number of values. That's what the sum of f is. Minus the square of the mean. This is standard deviation. That's the formula for standard deviation. Standard deviation. Standard deviation. So if you have to calculate any standard deviation in any question, this is what we're going to use. If the values appear more than once, we just basically we just multiply these values by the frequency. We just count how many we have. All right? It's in a nutshell, that is it. All right? This is what we're doing. This one is probability. So you notice only one formula. It also give you the formula from which you must know to calculate mean already from CSEC. Right? The same way you calculate mean in CSEC, the same way you calculate the number of components of any examples, we'll do it. And you have to be able to do mean for group data, and ungroup data. Remember, if you're doing mean for group data, simply you use the midpoint of the groups as your data. Use the midpoint of your groups for your as your data. All right? All right. So I'm going to just jump to some questions. This is our topic that we can just do by example. So we're jumping down, and we're going to look for only the statistics questions. Any question on it that is probability, we're not going to do that today. So see, here's number 6. First part here is probability. See? Talking about a dice toss. That's 4. A dice. And we're going to have something about some probability. See, determine the probability. So that part is a probability question. All this is probability. I'm skipping over that. That is probability. Determine the probability. That's the probability. We're not doing that today. So we'll do the topic, we'll come back to it. Don't jump into the part C though. This is part C. This is a box and width plot. And this one is shown vertically. Sometimes it is shown horizontally. Most times it is shown horizontally. All right? Now if I were to redraw this horizontally to show you how it normally is, right? It will basically look like this. I'm just going to put on the critical values, right? Critical information. Join it from left to right. So instead of going, so you read it from bottom up as compared to from left to right. And usually you have to put a scale on it, you know. So this will be a scale, right? And then right here, if we number the scale, let me finish it first. And then you have the top section up here. So if I put in the values, the lowest value down here is 4. Cut it down, you know. Lowest value down here is 4. So over here, I'm going to mark 4 right here. 4. All right. Then the value right here at this box, that looks like 7. It's halfway between 6 and 8. So it's 7. So right here is 7. So when I put it horizontal over here, I'm going to put that 7. Now remember, I didn't have to do this horizontally. Just that most times they are horizontal. That's why I'm showing you that. And then this value here also is 11. That's right halfway between the 10 and the 12. So it's 11. So I'm going to mark this right here as 11. So I'm going to put the 11 right here. So 11 right here. I will mark it. If you notice, this box is shorter than this box. Right? This is a longer box over here. This box is longer. That's the same thing I'm doing. I'm making this box on the right side longer. Right? So right here now is 11. And at the other end right here, the value is 17. 17. So you can see that that box is longer. This box is 6 wide, while this box is 4 wide. So it's longer on the right, to the right. Right? So the longer box is to the right. And then the last figure out here now, top figure is 20. Top figure up here now is 20. So let me tell you now, what this means, guys, is that this now represents a set of data. This represents a set of data in ascending order. What this is saying is that the lowest value is 4. The lowest value in the data is 4, right here, corresponding to this. The highest value in the data is 20 at that end. You see the values here, here, and here? Those are the quartiles. So this is Q1, this is Q2, and this is Q3. Those are the quartiles. So the space in between here represents your interquartile range. The interquartile range is the space inside here, right? Interquartile range. It is equal to Q3 minus Q1. So a box on which is a plot, it shows the lowest value down here, it shows the highest value up here, and it also shows the quartiles. That's what a box on which is a plot shows. It shows the quartiles. So it basically shows when your data is broken up into quarters, your quartiles. That's what a box on which is a plot shows. All right, it shows your quartiles. So I know that the lowest value is 4, the highest value is 20, and my lower quartile is 7. My middle quartile is 11. I remember the middle quartile is also the median. Q2 is also the median. And the upper quartile is 17. I just take this, what I did, I just took this box and whisker plot and I put it horizontal. That's all I did. So you can see it over here because it is normally shown horizontally like that. Normally shown horizontally. So we read it from left to right. This vertical one, we read it from bottom up. Reading it from bottom upwards based on the scale. All right, let's answer the question. Question says, scores of 30 students. So this is the scores obtained by 30 students. So no, 30 students. So n equals 30. Number of students or the number of data is 30. In a mathematics test, that were used to draw a box and plot. It said the total possible mark is 20. So these are the marks, and the total possible mark is 20. So it means that somebody got 20. More than one person got 20. So 20 was a mark obtained. And like the lowest mark obtained was 4. Looks like the lowest mark obtained was 4. All right. Remember, I represent the total, all the scores, and we are seeing the quartiles. All right. It says now, determine the median. The median corresponds to right here, Q2. That is the median. The median, Q2. The second quartile, that is 11. So the median Q2 is equal to 11. Done, that's it. 11, right? I say 11 marks. Right? 11 marks. But the data is in marks. 11 marks is the median. All right? Simple as that. Next question. Range of the scores. Range is the highest value minus the lowest value. So the range is 20 marks minus 4 marks, which is 16 marks. 16 marks is the range of the data. The highest value minus the lowest value. 16 marks. Then it asks us for the semi-interquartile range. Notice the word semi, it means half. The semi-interquartile range really is half of the interquartile range. That's what semi-interquartile range is, half of the interquartile range. And the interquartile range is Q3 minus Q1. So this is half of Q3 minus Q1. That's what we need to calculate. What did we say up here? Q1, based on the data, Q1 corresponds to this mark here. The lowest, the first line in the box is Q1. So based on that, Q1 is 7. But I already said Q2 is 11, which is also the median. And Q3 is up here 17. Q3 is 17 marks. Q3 is 17 marks. And so now we want half of the interquartile range. Interquartile range, we put it in here. So it becomes half of 17 minus 7. So the interquartile range is 10. But it is a semi-interquartile range of 1. Half of 10 is 5. So that becomes 5 marks. 5 marks is a semi-interquartile. Understand that? Understand that? Understand that, Kai? If anybody has joined. Understand that, Kai?
Yeah.
All right. It says now, comment on the shape of the distribution of the score. Now the shape has to do whether it is positively skewed or negatively skewed. Or they can call it right skewed or less skewed. But let me give an example of skewness. This one is positively skewed because the right side is longer than the left side. Give us some examples of skewness. If I have a box and whisker plot, where the boxes are even, but I have a whisker out here that is long and a whisker here that is short, then this is a positive skew. This is positive skew. Positive skew. Positive skew plot. Positive skew. Because the whisker on the right is longer. If the two whiskers are the same length, as is the case up here, looks like the two whiskers are the same length, we can check it. The distance between 17 and 20 is 3. So the whisker is 3 units long. And this whisker also is 3 units long, the difference between 4 and 7. So the two whiskers are the same length in this example. But this box on the right is longer than the box on the left. And so it is positive skew because this box is longer. So it can be positive. Skewness is determined by the length of the whisker and also determined by the length of the box. So the box alone can make it positively skewed. The box alone can make it negatively skewed. The whisker alone can make it positively skewed. The whisker alone can make it negatively skewed. Then the box and the whisker together can also make it positively or negatively skewed. So this is a positive skewed data because of the whisker. This is a positive skewed data because of the box. If I draw a box this way again, and I make them the same, but I put a short one on the left, on the right, and a long one on the left, this one is now negatively skewed. Negative skewed, negative skewed, negative skewed. It means that you have a lot of data on the left side relative to the quartiles. Right? Relative to the quartiles. Right? That's what it means. The data on the left side is spread out in terms of value. The values of the data on the left side is spread out. That's a negative skew. I can have a negative skewed one because of the box. So we have a short box here, so, and then we have the two whiskers the same. These are called the whiskers. These are the whiskers, and that is the box. So we call it a box and whisker plot. Box and whisker. Right? So the two whiskers are the same. This one also is negatively skewed, negative skew. Right? And the whiskers are the same. Then, as I said, you can have examples now where the box and the whisker are skewed. So you can have one like this, where you have the right side box is long, the right side whisker is long, and you have a short. This again is a positive skew. Positive skew box and whisker plot. Positive skew. All right? Giving the examples as we do. Positive skew. So far so good. So that's what you would say down here. That the data has a positive skew because of this box. And you're gonna say that Q3 minus Q1, Q2 is greater than Q2 minus Q1. Right? You can say something like that. You can say Q3 minus Q2 is greater than Q2 minus Q1. But the whiskers are equal, you know. Two whiskers are equal. The whiskers are equal, but the box is more on the right. Therefore, the data is positive. Data has a positive skew. Data has positive skew. Or data is skewed positive, or data has a positive skew. Data has a positive. I got the word positive. And the data is positively skewed. Anything like that, positive. To the right is positive, but sometimes it's right skewed, left skewed. When it's to the right, you can also say right skewed. So that said positive skewed, you can also say right skewed. Right, R-I-G-H. Data is skewed to the right. We also say that as well. Right? So again, it's positive or right, negative or left. But just use positive and negative. No matter make you confused. Let's use positive and negative. Right? So that's a positive skewed data. Next one. It said a student wants to determine the mean score for the data set. State one reason why it would not be possible. State one reason why it would be impossible, not possible, to determine the mean score from the box plot. Why you think we can't get the mean score from the box plot? They give us this box plot. Why is it that we can't get the mean from it? You don't know the individual scores. And for you to calculate mean, you have to have the individual scores. You're gonna say something like the individual scores are not known. The individual scores, the individual scores are not known. And for you to calculate mean, you have to add up the scores and divide by the number of scores. We know the number of scores, you know. We don't know are the actual scores. We don't know the sum of the scores unless they tell us. So we cannot get this. We cannot get to add up the scores because we don't know them. We don't know the actual scores. So we cannot get the mean because we don't know the actual scores. So we can't get it from the data as shown there. You have to give us something else first again. All right. Next one says, state the additional piece of information needed to determine the mean. We need the actual scores. Right? The additional data need is the actual scores of the students. All the students, you need for all the students. Actual scores of all the students. Because you want to be able to use the sum of the scores divided by the number of scores. We know the number of scores already. What is the number of scores? It's 30 because there were 30 students. That's all. It was 30 students, so we know the number of scores already. So what we don't know is the actual scores. We need to know the actual scores in order to get the all right, okay now. So I'll give us some information now. Given that the sum of the 30 scores is this. So you know what this information is? This is the sum of the scores, you know. It's 254. So we don't know that the sum of x is equal to 254. Given that the sum of the 30 scores is 254, and the sum of the square of the scores, you know, the sum of the square of the scores is 4994. Remember, this is used in calculating the standard deviation. Standard deviation written with an S, sometimes it is written with that symbol. Standard deviation. I don't remember the name of this symbol, but sometimes written with that symbol. This is used to find the standard deviation, the sum of the square of the scores. But that's the information they're giving us. Sum of the scores and the sum of the square of the scores. Now that we know the sum of the scores, we can now find the mean. Remember the n equals 30, you know. So once you have the sum of the scores and this number of scores, you can find the mean. It says, determine the standard deviation of the data. If you're going to calculate the standard deviation of the data, you need the mean. You have to find the mean. Because we're going to use the formula now. So watch this now. Now that we know the sum of the scores, and we know the number of scores, we can now calculate the mean score, which is x bar. It is equal to the sum of the scores divided by the number of scores, which is equal to 354 divided by 30. 30. What is work out to? The mean score. What is out for me? 354 divided by 30. That's 11.8. So the mean score is 11.8. They're asking us for the standard deviation. So I want to look at the formula for standard deviation. I think I wrote it out on the right side. See here? This is the formula we're going to use. That's why they told us this. The sum of the square of the score, because we need it right here. So this is the formula for standard deviation, and it's on the formula sheet. See there? This is it. Just on the formula sheet, I put that F right here. So that is if you had a repeat data, but the sum of f times x squared doesn't matter. The same as the sum of x squared. Here. So all we have to do now is drop these values in the formula. We have standard deviation. So I'm going to write it. Put it in here so now. Remember, it's either S or we can write this symbol for standard deviation. But I think S is standard deviation for sample, and this is standard deviation for population, which is a difference. There's a difference. We use the S that they use at the formula sheet. It's the S. Standard deviation for the sample becomes the square root. Dropping the values in this formula. The sum of the square of the values, which is the 4994, divided by the number of values, which is 30, minus the mean square, which is the 11.8 squared. Whatever that work out is the standard deviation. Simple as that. So that works out to the standard deviation. It's a formula. All right, so it's not difficult, but it's a formula to use. Come on, calculator. All right, I'm going to put it in that calculator. So square root of a fraction. On the numerator, I have 4994 divided by 30, and I'm subtracting the square of the mean, 11.8 squared. That's it, 5.22 marks is the standard deviation of the marks. That's a measure of how the data spread out from the mean score. 5.5 average, 5.22 spread out from the mean score. 5.22 is the standard deviation. 5.2. All right. That is that. Question done. Well, before I come out of the box and whisker, let me tell you something now about what we call something that we call outliers. We'll just talk about outliers. I don't think they'll ask you about outliers. Let me show you still, just in case. Outliers. So sometimes what will happen is that you'll have values, sometimes extreme values out here and out here. They might fall outside a particular range of values. If they fall outside a particular range of values, then they are called outliers. Now, what is that particular range of values? That particular range of values is Q1 minus 1.5 the interquartile range, 1.5 the IQR. That's the low end. You want it to be less than or equal to, that's what you want your scores to be, Q3 plus 1.5 the interquartile range. Any value falling outside of that is an outlier. Any value falling outside this range is an outlier. What did we get for the interquartile? The interquartile range was 10, remember? Remember, the interquartile range is 17 minus 7, which is 10. You see it now, and the Q1 is 7 minus 1.5 times 10. You want that to be less than or equal to, in other words, you want your value to be in that range. Q3, which is 17 plus 1.5 times 10. Any value that is outside this range is an outlier. You want your values to be in that range. Any value within that range, right? Any value that you have within that range is okay, not an outlier. This one coming out negative because it becomes 7 minus 15. 7 minus 15 is negative 8. Less than or equal to x, less than or equal to, this works out to 17 plus 15. 17 plus 15 is how much? 32. 32. The 20 is within this range, and the 4 is within this range. So all the values in here are within the range, and so there are no outliers. There are no outliers. This data. None of the data can be considered an outlier. So I want you to remember this. I don't think they're gonna ask it. I don't think they don't mention outliers in the syllabus, but just in case, that's how you calculate the outliers. That was the 2021 paper for statistics. We'll come back and start with the probability and let's do the probability question and work our way out. So let's look at the 2019 paper. Let's look at the 2019 paper. 2019. Let's get the 2019 paper. All right. But there was no exam in 2020, right? So that was 2021. This one now is 2019. Let's bring it up. I remember looking for the statistics question, leaving out the probability question. We'll do the probability another day. 2019. All right, so jumping down to number 7. On the old syllabus, it was number 7. And your syllabus was number 6. New one. With the same kind of question. All right. So this now, this is a stem and leaf diagram. It's a stem and leaf diagram to give you this question. Right? This is called a two-sided stem and leaf diagram. Right? Two-sided. You have a stem and leaf on this side for the girls. You have a stem and leaf on this side for the boys. Two-sided stem and leaf. All right, so what is stem and leaf word? Most time when I give you a stem and leaf, they give you a key. This is the key that explains the value of the stem and leaf word. So the values in here are called a stem. And the values out here are called the leaf. The leaf values are usually your ones values in a number. Usually your ones values in a number. Same thing over here. Over here is the leaf as well. These are your ones values. Your ones values. You usually put your tens values in here and your 100 values in here. Well, you can set up a stem and leaf for any rule number. Usually that's what it is. So you always have to put a key. You can set up a stem and leaf with decimals. Right? But usually you put a key to explain it. Right? You put a key to explain your stem and leaf diagram. Now, based on this key, they are telling us that when you have 8, no, look at it. For the boys, you know, this is the boy side of this. So this figure represents the stem figure. This figure represents the leaf figure. That's why this is 28. 28. But for the girls, this is on the right side, which is the normal way to express it. But it's just one side, it's usually just to the right like that. Then it means that the 2 is a stem and the 8 is the leaf. And so you put them together, I get 28. So if I were to give you some examples from this, this 3 and this 5 means that this 5 really is 35. That's what it means. Good? That 5 really is at 35. And if I do one of the boy figures, this 4 and this 1 means that this one really is a 41. Really is a 41. That's what it means. All right? And it means that there are 1, 2, 3, 4 41s in this line. 4 41s. This and this is a 45. This really then is a 45. It's a 45. Right? This means 51. This is 51. 51. 51. That's what this means. 51. That represents a score of 51. So it's just a compact way of representing the data, and you don't have to be writing these numbers a lot of times. 20s, the 30s, the 40s, the 50s, you don't have to write them on board. So that you can compact a lot of data that way. That's stem and leaf diagram. That's the advantage of a stem and leaf diagram. All right? And then you can also count how many data you can count, how many girls. That's what the data is. The weight is the weight of the students. You said the weight of students in grade 5, in a grade 5 class are displayed in the stem and leaf diagram. So the weight of the students we're looking at. So these are the girls, and we can count how many girls are there. But these are the stem values, you know. So if you count these, you know how many girls. So this is 3 girls right here, so. Then 1, 2, 3, 4, 5, 6, 7 girls right here, so. And then 4 more girls right there, so. So the total girls you have right there, so is 14, right? 1, 2, 3, 4, 5, 6, 7. 14 girls you have. 14 girls. In terms of the boys, you have 2 right here, so. You have 5 right here, so. You have 1, 2, 3, 4, 5, 6, 7, 8 right here, so. And you have 1 more right there, so. Not 8, 1 more right here, so. So in terms of the boys, you have 16 boys. 16 boys. And you have 14 girls. 14 girls. So you have a total of 30 students. To put them all together. 30 students have been on. Right? I was giving you some information where you get the information from it. So it says state the number of students. At the top of what I was 30. Right? So they were relative marks. 30 students. 30 students. So there are 16 boys plus 14 girls. That is 30 students. So we have the weight of the students, so we can count how many we have. 30 students were measured for weight. All right, 30 students. Now, this thermal diagram, right now, the data is in ascending order already. Hope we can see that. The data is in ascending order already. So I have the lowest value up here, the 20s, they have the 30s, they have the 40s, they have the 50s. Additionally, the values increase this way outwards on that side, and they increase this way outwards. So it's always extend from the same out to the end of the loop. The values increase. So the values are in ascending order. What I can also do, I can take this stem and leaf diagram, two-sided, and make a one-sided stem and leaf diagram to just show all the students. To show students. Not the boys separate from the girls, to show the students. I can also do that. Right? And it might serve me well to do that actually. Based on what they want. But remember continuously. And usually when we get data like this, they're gonna ask for median, interquartile range, they're gonna ask for median, quartiles, they might ask for a box and whisker plot from the information practice. That's what they usually do in these questions. Right? Well, let's see what else is. See, right away they answer that. As I was just saying. Construct a box and whisker plot for the boys and the girls combined. They want a box and whisker plot. For you to do a box and whisker plot, you need to know the lowest value, the highest value, and you also need the quartiles. And a box and whisker plot is a scaled drawing. You can put on a graph paper. If you sketch it, it must be on a scale like you put on a number line. It is a scaled drawing, not just a sketch. You must carry a scale. So let's set it up. I'm gonna do one combined box and whisker plot. I'm gonna do a combined box and whisker plot, right? So I'm gonna do a combined boys and girls combined. Since I want me to do a combined box and whisker, I'm gonna do a combined plot. I'm gonna put the 20s, the 30s, 40s, and the 50s. Those are the weights. Remember, it's the weight we're talking about. So that is my step. Then now, in the first line in the 20s, I'm looking at the 20s now. I have to go from in ascending order. So there are 3 8s and 2 9s. 8, 8, 8, 9. Huh? 2 9s. Yeah, 2 9s. Sorry. In the 30s, I still have to go from in ascending order. So there are 2 2s. There are 2 3s. What comes next? There's 1 5. And a 6? No. 7, 1 7. 3 8. Let's say run out of space. Let me make that a little smaller. And there are 3 9s. In the next line, in the 40s, there are 3 zeros. That's 40 kilograms. There are 1, 2, 3, 4, 6 ones. 1, 2, 3, 4, 5, 6 ones. There's a 2. And then there's a 5. There's 1 5. Good. Then in the 50s, there's only 1 student, a boy who's 51 kilograms. 1 boy is 51 kilograms. Wow. And I must count and make sure that there are 30 values there. 30 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. I'm getting 29. Something missing. Because it's supposed to be 30. It's supposed to be 30. 1, 2, 3, 4, 5, 6. There are actually 6 ones. 1, 2, 3, 4, 5, 6. There's 1, 2, and a 5. There were 3 zeros. Something like that. In the 30s, there were 2 3s. So whenever I go to drum from the beginning, maybe it's not 30 boys, maybe not 30 students. Let's check it over. This was 3, 1, 2, 3, 4, 5, 6, 7, 4. So there's 14 that. And over here says 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, and 1. Oh, it's 15 over here, so I made a mistake. 15 boys. This is a good thing I was doing. That says 15 boys. 15 boys, so there are 29 students. 15 boys and 14 girls. 29. All right, so good one. All right. So remember now, we need the quartiles. So the box down with we need the quartiles. So the lowest value is going to be 28. The highest value is going to be 51. We need the quartiles. Now let me show you how to find the quartiles. Something from CSEC. Something from CSEC. The position of Q1 is 1/4 of the n plus 1 term. That's where it is located. That's a quick way to find it. 1/4 of the n plus 1 term. Remember I said in the middle of the data, and I said if you have 29 values, you're going to have 14 on the low end, 14 on the top end, and the median and the middle. So the median is going to be the 15th value, don't it? But a way to calculate it and don't have to do that is to use this formula that we learned in CSEC. That's why I teach these things at CSEC level, because we use them here now. So it's 1/4 of 30. 1/4 of 30. Eh? No, 29 plus 1. N plus 1. 1/4 of n plus 1. In a continuous data, we have our group data. 1/4 of n plus 1. So it's 30 divided by 4. I'm going to explain something. It's 7.5 term. 7.5 term, 0.5 term means it is the average of the 7th and the 8th term. Let me explain to you why it's the average of the 7th and the 8th term. Remember, I know it's 29 students. So you have 29 values out here. So 29. When you divide it and take out the middle value for the median, you take out the middle value for the median and drop it right here, so which is the 15th value. You're gonna have 14 values left down here, so 14 values. And you're gonna have 14 values, because the median is 1 value, you know, 1 value. And you're gonna have 14 values left up here, so 14 values. Remember, Q1 is the median of those 14 values. Good? The median of those 14. So when you cut the 14 in half, you're going to get 7 and 7. You have to add one in the middle between the 7 and the 7. So basically then it becomes the average of the 7th and the 8th value. The average of the 7th and the 8th value. So that's what 7.5 means. So the average of the 7th and the 8th value. So watch me now. Oh, what is the 7th value and what is the 8th value? Let me take this off. You can get the values by counting them up here. See here, 1, 2, 3, 4, 5, 6, 7. This is the 7th value. This one is the 7th value. This is the 7th value. That is the 8th value. I want the average of those values. The 7th value is 32. So that is 32 plus this value is 33 over 2. That is my Q1 value. So Q1 equal that. Understand that? It's the average of the 7th and the 8th value. Remember the form. 7th and the 8th value. So Q1 equals the 7th plus the 8th value divided by 2. That's what 7.5 means. Halfway between the 7th and the 8th value. So Q1 is equal to 1, 2, 3, 4, 5, 6, 7. Those two what I've circled are the 7th and the 8th values in the data. 7th and the 8th values. So that is 32 plus 33 divided by 2. So basically that's 32.5, right? Halfway between 32 and 33 is 32.5. So that's 32.5. That's the position of Q1. Then Q2, we need Q2 as well. The position, which says the 15th term already, right? But if you never know, the position of Q2 is half of the n plus 1 term, which is half of 30, which is the 15th term. So I put 7.5 up here. The 15th term. So we need the 15th term now. Remember, this is the 8th term now. This is the 8th term. 9, 10, 11, 12, 13, 14, 15. So the first 9 is the 15th term. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the 15th term. That is the 15th term. And the 15th term is 39. So it means that Q2 is 39. So Q2 is 39. So I said I give you a vertical space to do the plot, and I have to calculate all those things and how to do the plot. Kind of weird. They give you this. What did they give you a graph to do the plot on? Did they? No? Kind of weird, you know. You have to calculate all those things and just give it the space. Construct one box and whisker per grade 5, boys and girls 5. Weird, that the space is so small. You have to just juggle in the exam, squeeze it up, do some of the calculation on the side, that's one thing. You have to just look at the space that you have one thing. Then we need Q, we need the upper quarter. So the position of Q3 is 3/4 of the n plus 1 third. That's 3/4 of 30. And you have to average 2 values again. 3/4 of 30 is 1. Because 7.5 times 3, 7.5 times 3. That's 22.5. 22.5 term. That means you want the average of the 22nd and the 23rd term. That's what they want. The average of the 22nd and the 23rd term. Remember, this is smaller. The average of the 22nd and the 23rd term. All right, let me do it in red. So Q3 is the average of the 22nd and the 23rd term. So we need to find those terms. Huh? 1 and 1, you know, 1 and 1 and there's 41 and 41. Good, so let's look at it. So remember, this is the 15th term, right? And I'm trying to find the 22nd and the 23rd, 22nd and 23rd. So this is 15, 16, 17, 16, 17, 18, 19, 20, 21, 22, 23. That's 41 and 41. Average of 41 and 41 is 41. So it becomes 41. This is 41 and this is 41. All right. So talking about this and this. It's 41. So I know the information to do my plot. Right? Let me sketch it up over here. has to be drawn to scale. So the lowest value is 28. 28, I'm looking for 28, 32.5, 39, 41, and the largest value is 51. All right, so you have to draw something that is to scale. So I'm going to draw a scale like this, starting at 28, going up to 51. Let's say this is 25. 25, 30, 35, 40, 45, 50, 55. So let's say that is it. We start, draw the line through here. And that's 25, 30, 35, 40, 45, 50, 55. I'm going to use this. I'm going to increase it like that. So this is it. I'm going to put my box and whisker pattern this. So ready now. Let's draw it in purple. So my first lowest value is 28. 28 might be somewhere around here, so 28. Then my first box is at 32.5. 30 here, so 32.5 is right in the middle here, so that's my first box. First line of my first box right there. Then my median is 39. 39 is right before the 40. I'm gonna put it right here. Then my upper quartile is 41. It's 40 here, so 41 might be right here. So a radius that is left skewed. The left box is longer than the right box. And you draw the box. You go like that. The last value is right about 51, right here, 51. So that the whisker make it long. Right? So if we go by the whisker, it is right skewed. If we go by the box, huh? This one, you have a comment on it. Tell them that the whisker, you have to talk about, you have to discuss it. It kind of balance out, you know. Because where the whisker is long on the right side, the box is long on the left side. So it's still kind of balance out. The whisker on the right, the whisker on the right is what? 10. The whisker on the right is 10. Right? While this box inside is so much. Or we can measure it from the center, from this, you know. From 39 out to 51 is how much? Let's compare. Huh? What do you mean 6.5? What do you mean? You don't have to guess no value. You can know the value. You must write this at 39. And right here, so was what? It was 32.5. Oh, so you mean, right. So it's more on the right because the whisker longer than the box. Yeah, so it's more right skewed. Positive skewed. Yeah, also positive skewed. But that's my box and whisker right here. Right? And if you like, you can put on the values. You can put on the values. You can write 28. You can write the 32.5. You can write the 39. And the 41. And the 51. I wonder if this is the outlier. I wonder if the 51 is the outlier. We can check it, you know. You can check it. The interquartile range is 41 minus 32.5. Q3 minus Q1. Write this out for me. You can check if it's an outlier. 51. What I work out to? Huh? 41 minus 32.5. That's 8.5. Remember, you want your range to be greater than or equal to Q1 plus 1.5 interquartile range. Q1 is 28. No, minus 1.5 interquartile range. Now, let me say Q1 minus Q1, which is the 32.5. 32.5 minus 1.5 times 1.8. 1.5 times 8.5. Not 1.8, 8.5. And up here now is Q3, which is the part 1 plus 1.5 times 8.5. Write this out for me, this and this. So I get it in the outliers. This is 19. 19.25. 19.25. So left value good. Left value is bigger than 28 is bigger than this. So okay. Over here, so becomes 41 plus 1.5 times 8.5. 53. So the 51 is good. Eh? 51 is good. 51 is within this range. Right? Within, because this is say you can go all the way down to 19.2 something down yourself, to 53 point something of yourself. Box and whisker is entirely within that range. So, but anyway, they didn't ask us that. But this is the box and whisker plot. That's what they asked us to do. They said the standard deviation of the weight of the boys is 5.53. Determine the standard deviation of the weight of the girls. Provide an interpretation of your answer. Compare of the girls, compare with that of the boys. So we need to calculate the standard deviation of the girls. When I use the formula get, or the formula go again. Standard deviation is equal to square root of the sum of x squared over n minus the mean squared. That's the easy way to do it. So we'll have to calculate all of those values. Sum of the square of the x values, and then the mean. We have to calculate the mean of the values. So let's do it for the girls. Focus it on the girls, right? So doing the mean first. Let's do it on the right side. Do it for the girls. The mean equals, add up all those values and divide by 14. If I add them up and divide by 14. So it's 28. Okay, all right, 2 times 28. 2 times 28 plus 29. And it's 2 times 32 plus 2 times 32 plus 33 plus 35 plus 3 times 38. And then you get plus 40 plus 2 times 41 plus 42. Those are the girls. Add all of them. Add them up. And you're dividing that now by 14. Add up all of this and divide by 14. That gives you the mean for the girls. So it's 2 times 28 plus 29 plus 2 times 32 plus 33 plus 35 plus 3 times 38 plus 40 plus 2 times 41 is 82 plus 42. I'm getting 495 over 14 equals divided by 14. I get 35.4. That's my mean. Then I need the sum of the square of the girls next. I need the sum of the square of the girls' score. See there? Square the girls and add it up. Square the girls' values and add it up. Alright? Ready now. Sum of x squared equals, ready now. Sum of x squared. So it's 2 times 28 squared. 2 times 28 squared plus 29 squared plus 2 times 32 squared plus 33 squared plus 35 squared plus 3 times 38 squared plus 40 squared plus 2 times 41 squared plus 42 squared. And that's that. I think some characters can put in the values and some characters can work more for you. If the characters that can do it, I think they have to give you a marks. If the characters that can do it. Right? But some characters can do it. Marks for this. 5 marks. I just need to do the work. Still 5 marks. So anyway, let's do this now. Put it in the calculator. Can do this for me. Work this out for me. Work out this all of this. 2 times 28 squared plus 29 squared plus 2 times 32 squared plus 33 squared plus 35 squared plus 3 times 38 squared plus 40 squared plus 2 times 41 squared plus 42 squared. That's the sum of the square of the values. We need them to drop them in the standard deviation formula right here. And then we'll go to I have the mean already. The mean is 35.4. So let's need to this work out. Get it, Fiona? Yeah, work it out. All right, let me work it out, Minecraft. All right. So it's 2 times 28 squared plus 29 squared plus 2 times 32 squared plus 33 squared plus 35 squared plus 3 times 38 squared plus 40 squared plus 2 times 41 squared plus 42 squared equals. That comes out to be 17829. Drop in a minute now. Equals square root 17829 divided by how many girls are there again? 14. 14 girls minus 35.4 squared. That's my standard deviation. Let's see what we get. All right, so putting it in this one. So now here's 14. Up here, we have 17829. And here we're subtracting 35.4. 35.4. So we get 4.5. This is 4.51. So this is standard deviation for the girls is less, right? So it means that the weight of the girls are less widely spread from their mean in comparison to the weight of the boys. Simple as that. but their standard deviation is less. Right? Simple as that. The weight of the girls, remember the weight we're measuring, the weight of the girls is less widely spread from their mean weight. Compared to that of the boys. Simple as that, because the girls' standard deviation is less. If you want to do it from the reference of the boys, you could say the weight of the boys, weight, so here's a weight of the girls, weight of the girls, talking about the weight of the girls is less widely spread from their mean grade compared to that of the boys. We're doing it from the reference of the boys, we could say weight of the boys are more widely spread from their mean weights in comparison to those of the girls. All right. So since the girls have a lower standard deviation, it means that their mean grade is less widely spread from the mean. Their weights are less widely spread from their mean weight. That's it. Determine the number of students in the 20th percentile. Determine the number of students above 20th percentile. So since there are 30 students, we need to know what position. Is it 20? How many students were there again in all? 30. 29, right? We need to know which student is in the 20th percentile first. All right? So see here now the position of the 20th percentile. It's basically 20% of 29. That's the position of it. 20% of 29 students. Tell you which one of the students or what position that 20% are occupied. Remember that you divide 29 students into percentages. Right? So it's 20% of 29. So it's 20% of 29. 0.2 times 29. And I get in 5.8. So 5.8, because you count this student, you approximate that to the nearest whole number. So that is the sixth student, or the sixth weight. Sixth weight, or the sixth student in the data. So you need to find out what is the weight of the sixth student. And you want to know how many weights are now above that weight. So you're going to look now and find the sixth weight in the data, the sixth weight. And if you're talking about all the students or just the girls? All the students. So we need to use the combined table that we use. So we're looking for the sixth weight in the combined one that we use. The sixth weight we're looking for. All right. So let's mark it in black. So that's 1, 2, 3, 4, 5, 6. So this one is the sixth weight. Sixth weight is a 32. So the 20th percentile weight is 32 kilograms. And guess what we think about it now? This is also 32. So you can't include that. You want the weights that are above 32. So you can't include this weight because this one also is a 32. So the rest of them you have to count. Right? The rest of them. My question asks how many students? How many students? So basically it's 7 students. 7 students have a weight that is 32 or less. So the ones that are more is the rest of them, which is 29 minus 7. That is 29 minus 7, 22. 22 students. So that is 22 students above the 20th percentile weight. 22 students. All the students up here, all these students up here, and up here, up here, 22 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 of them above the 20th percentile weight. 20th percentile weight is 32, but this also is 32. So you can't count that as a weight that is above the 20th percentile. 20th percentile weight is 32 kilograms. So you're looking for all the weights that are more than 32. So the ones up here, so up here, so and up here, so and up here, so you cannot include the 32. You can't count that as one above. 32 is not above 32. We're looking for the ones that are above 32. So it's 22 students. All right, don't necessarily probability. 5 is probability. So I want to skip over that. So far, so good? Huh? Did you get it? All right, we could put 2018, the mark something there. And basically, you know, if you do a couple of these questions, the majority of them asking the same thing. The majority of them asking the same thing. So the standard deviation question, we do quartile, with box and whisker, we do a stem and flat. So sometimes they ask for sample space at a probability. Right? It's a probability, so now we're going to probability. Skipping over probability. So let's look at 28. Can maybe try to do a session tomorrow or so? Do the rest of the questions. I want to run through all the questions on this topic. I don't know. I like the repeat questions that are similar. Huh? I'm gonna have tomorrow. I have to go to work tomorrow. I'm coming here to start off a mock exam with the students tomorrow. But then I have to go to work. So that will be sometime during the day. I don't know exactly what time it is. So I have work tomorrow. So I'm gonna start off the students with a mock exam. And then take it from there. All right, so one here so on the screen. I'm gonna leave it, make you try that one here a little bit. So we can do this one a little bit. Both of you. This question says the number of runs scored by a cricketer for 18 consecutive innings is illustrated in the following stem and leaf. These are the scores that these are the runs that he scored. So these are 2 runs. These are 0. This stem value here is 0. So we say this is 0, 2 runs, 3 runs, 6 runs, 7 runs. But this now means 10 runs. 1, 0, 10 runs. This means 13 runs, 15 runs, 18 runs, 19 runs. You're going into the 20s next. Where is it, man? Where is it? What's that here, sir? Sorry about that. I don't know what I'm about. Right, so you're going into the 20s here, so now. 24, 24, 26, 28 runs. Those are the runs he scored. 31, geez, I keep doing this. Keep going on. I'm sure they're gonna ask for box and whisker plot again. That's what these questions go all the time. Right, so this is 45 runs, 47 runs. We said determine the median. How many runs? How many? 18 innings. So if there are 18 innings, there are 18 values. Why keep doing that? Jeez, I don't know why I keep doing that. There are 18 values there. The median, remember, is about 9 and about 9. So the median is the average of the 9th and the 10th value. Right? Or you can do it this way. Remember, is half of 18 plus 1. Half of n plus 1. That's where the median is. Right? That works out to be how much? 19 divided by 2 is how much? 9.5. That is the 9th value and the 10th value divided by 2. All right, so use up the formula. So I'm going to work this one out for me. Let me see what this asks. That will give you the median. Then I want to determine the interquartile range, which is Q3 minus Q1. Remember the position of Q3, position of Q1. Position of Q1 is 1/4 of the n plus 1, and it's 18. And the position of Q3 is 3/4 of 18 plus 1. So find the values for me. And then after finding, we're going to subtract Q3 minus Q1. This is what is asked of me. It says in the space below, construct the box and whisker plot. Come on, do it for me. You must do this one now. This is what is asked of me. The only thing is a probability. So we're not going to do this one. That's a probability. All of this is probability. All right, so you just start to do. Just to do the median, do the interquartile range, and then plot the box and whisker plot. Do the box and whisker. Try that one for me, possibly. Try that one to Kai. Use the data, get the median, get the interquartile range. It's 18 data there, 18 scores. All right, so you're going to count and find the scores. Remember? 9 and 9. After you divide 9 and 9, the bottom half, the median score is going to be the 5th value. As if the 9 values, you want the median, the bottom half going to be 9 values. The 5th value is going to be the Q1. You can use 1/4 of the n plus 1/3. 1/4 of 90. All right, work it out for me. It's only 18 values enough, so you can easily break it down. Right? So you can have the bottom half of 9 value. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the bottom half of the data. You know? This is the bottom 9 values. And then this is the top 9 values. And this is the median right here. That is Q2, you know. Easy like that. You have 9 at the bottom and 9 at the top. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7. This is 8. It's 18 values, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. All this works. Oh, it's 9 and 9. Right. So one of them are for it here. Sorry. So it's 9 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here. 1, 2, 3, 4, 5, 6, 7, 8, 9 down here. So see the median. The median is going to be the average of this value, the last value in the 9, and this value. Average of those two values. That is 19 plus 24 divided by 2. Those two will give you the median. Average of those two middle values give you the median. All right? And then now of these 9 values now. 1, 2, 3, 4, 5, 6, 7, 8, 9. So you want 4 and 4. So this is the median. This is median of the bottom half. 1, 2, 3, 4. This is the median of the top half, bottom half and top half. So this value becomes Q3, and this value becomes Q1. Q3, that is 31. 31. Q3 is 31. Q1 is 10. And then this is Q2. Q2 is the average of these two, but I put them in green. A purple. This value, that's 9th value, and that's a 10th value. Average them to get the Q2 right here. Right? That gives a Q2. You have Q3. Then remember the interquartile range down here. It's Q3 minus Q1. Or that out. Alright. You understand what I have on the screen? You understand how I get the Q1 and the Q2 and the Q3? You understand how I get them, Kai? Kai, understand how I get the quartiles?
Yes.
Alright. Same as how you line the data in a straight line, so then put them in a stem and leaf diagram. It's the same methodology, really. Write that out for me. I'm going to pause the video a bit. Remember to start them, but just go to the office with some paper and come back. All right. All right, so I'm going to run through it. So you can actually reason out the values. Since there are 18 values, you're going to divide it half and half first. So you have 9 values and 9 values. 9 values down here and 9 values up here. That's all 18 values. And so you have to calculate the median value inside here. This is the 9th value and this is the 10th value. So the median is the average of the 9th value and the 10th value. So it's 1, 2, 3, 4, 5, 6, 7, 8. This is the 9th value and this is the 10th value. So we're taking the average of those two. So that's what I had before. So Q2 is going to be equal to the sum of the 9th value, which is 19, see? 19 and 24. 24 divided by 2. That's what Q2 is. And it works out to be what that is. 19 plus 24 divided by 2. 21.5. 21.5 around this is median. Alright. Then now you have 9 values down here now. You have 9 values down here. So if you have 9 values down here, it must be divided in the middle. 5th one, then divided 4 and 4. So the 5th value is one in the middle. The 5th value is Q1. Based on this, the 5th value, 1, 2, 3, 4, 5. So this is the 5th value. 5th value is at 10. So Q1 is 10. Then up here now, you want the 5th value this way. So the 5th value after you have your 9 values. It's the 5th value on this half. Or it can also be the 5th value from this end. Right? From this end. So the 5th value this way or the 5th value that way. So we can work the 5th value from the back. So it's 1, 2, 3, 4, 5. So this is the 5th value, which is a 31. So the value in the middle is 31. Q3 is 31. This Q1 is at 10. So this becomes 31 minus 10, which is 21. So the interquartile range is 20. You got 21 for interquartile range? Huh? The interquartile range? Huh? Q3 minus Q1. What did you get for Q3 and Q1? It's 31. All right, good. Now what else I want us to do? The box and whisker plot. So we have all the values we need for the box and whisker plot. The lowest value is 2, and the highest value is 47. So going between 2 and 47. So going 2, and the lower quartile is 10, and the median is 21.5, and the upper quartile is 31, and the largest value, as we said, is 47. So we need values in that range. So I'm gonna do a line, and let's say we're going up by 5. So 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So that's 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. All right, let's draw it in purple. Those values are 2. 2 is about right here. All right, 2 is about right here. About right here is 2. Next value is 10. That's where the first quartile is. I'm gonna put a line there for the box and draw my whisker. Then 21.5. So this is 20, this is 25, 21.5, maybe somewhere around here. So I'm gonna put a box line there. That's my second quartile, my median. Then 31. 31, about here's 31. So I'm gonna put another box there. Right, so line from a box. Boundary from a box. Quartile. Then my whisker goes out 47. 45 here, so 47 is about around here. So I'm gonna put my whisker in line with that and go like that. That's my box and whisker plot. Right? It looks relatively like it right skew. This whisker is longer. This box looks longer, but this whisker looks longer. This whisker is definitely short and this one. So I would say it is positive skew. All right, I would say it is positive skew. Construct it and comment on shape of distribution. I say it is positive skew. Positive skew. Positive skew. That question is done. So let's look at 2017. All right, so if you see any now, that is just like this, I'll leave it for them for you. So I'm looking for any now that is different from what we have done before, right? But these questions are basically more and more the same. All right, so I don't want to waste time, spend time doing more of the same thing. So we're looking for now any that might be set out a little bit differently. So if it's a straight stem and leaf and I ask for standard deviation and the box and whisker, then we'll just skip over them and allow you to do them. I see that it's very easy now. That aspect of it. This part of it is statistics. All right, so this is the different process. It has some mean and stuff on the data. All right, so this is like a different question. So obviously it's probability. So they want a tree diagram. So I'm gonna do this. I'm gonna do this know the probability. I want a tree diagram there. So. And that's probability. I'm not going to that part. What we do, the regular statistics, says the table shows the length in centimeters of 20 spindles prepared by a carpenter to build a railing for an existing staircase. There are 20 values, 10 in this line and 10 in that line. And are they in ascending order? Yes, they are in ascending order up this way and then up that way. All right, so the data already is in ascending order. So I want us to tell them the mean. So the mean is just adding up all these values and dividing by 20. Good? All right, so this will be equal to the sum. So that's right, it's going to be the sum of the values divided by 20. I won't even bother work it out. But we don't need it to do anything. We don't need it to do anything. This one is a straightforward. They want the mode. The mode is the value in the middle. So there are 20 values is the average of this 10th and 11th value. See that? If there are 20 values, it must be the average of the two middle values. The 10th and the 11th value. So that you have an equal number of values down here and up here. So the value in the middle will be the average of those two values. If you don't remember, no, Larry, not the mode. The mode is the one that occurs most frequently. Ooh, I'm answering the median. The mode is the one that occurs most frequently. Anybody that repeats. This is the only value that repeats. So the mode is 25.2. Are there any units? Centimeters. Centimeters. 25.2 centimeters is the mode. Then the median now is the one in the middle. So if you want to find the position of Q2, it will be half of 21. 20 plus 1 is 21. That gives you what? 10.5. 10.5 means the average of the 10th and the 11th value. Average them. This is the 10th, that's the 11th value. They put two values in the middle. You have to calculate the average of those two values. And remember, they won't be included in the top and bottom half of the data is even number of data. All right, this is the 10.5 value. So it basically then is equal to 24.4 plus 25.2 divided by 2. When they give an answer, you see centimeters, it's the same unit of the data. So it's 24.4 plus 25.2 divided by, so that's 24.8. So when you put in the median in between these two values, when you put the median in between them, so you drop the median, let's say I drop the median right here. Let's say I drop the 24.8 value. I'm dropping it in between these two. So I'm dropping it in between those two. What it means is that all these values are now in my bottom half. All these 10 values are now in the bottom half of my data. And all these 10 values are in the top half of my data. And I need those to calculate interquartile range. But to calculate interquartile range, I need my Q3 and I need my Q1. Q1 is the median of the bottom half. So I know what the median of these 10 bottom values. So if it's 10 values, you divide it 5 and 5 is the average of the two middle values, the fifth and the sixth value. 1, 2, 3, 4, 5. So the median is the average of these two values right here. Not the median of the bottom half, which is Q1. Average of these two values. Give me Q1. And then now the median of these two middle values on the top half will give me my Q3. So that is 11 plus 11 plus 12.6 over 2 And down here it is 29.1 plus 30.4 over 2. Those will give me my Q1 and my Q2. So it's 11 plus 12.6, 23.6, and divide that by 2, 11.8. And then down here it is 29.1 plus 30.4, and divide that again by 2. So Q3 becomes 29.75. So I'm just subtracting them down here now. 29.75 minus 11.4, 11.8. Subtract. That's 70.95 centimeters. That's my interquartile range. The one that is 7 interquartile range, I will divide that by 2. But that is for that question. The rest of it is probability. So we'll do it in another class. All right? Probability. We'll do probability in another class. This question was mostly probability. All right, we're going to look at 2016. 2016. So I said the question look the same as any I've done before. You just skip over it. There's a stem and leaf, box and whisker. And similar to any other question before, I'm just going to skip over it. You can do it for homework. But this guy is just the same thing they're asking you with different numbers, really. All right. This one is a bit different. All right. This one says, use the data set provided below to answer the questions which follow. Construct a stem and leaf diagram to represent the data. Give data. All right. When you construct a stem and leaf diagram, you have to put in a key. Now the stem, all of these numbers are just 2 digits. Notice. All of these numbers are just 2 digits. So there are numbers in the 10s, 20s, 30s, 40s, 50s, 60s, 70s. So your stem therefore is going to start at 10. Right? So I'm going to write stem like this, put the stem like this. I'm going to put my 10s, my 20s, my 30s, my 40s, 50s, 60s, as you go up to 70s. That's the 75, 70s. That's my step. And the leaf now will be the ones figures. Ones figures will be my leaf. So I'm just going to do all these values. It is already in ascending order. So my ones stop right here. These are my ones, are my 10s. 5, 6, 8, 8. I don't put any comma between them. 5, 6, 8, 8. Those are my 10s. And my 20s. My 20s are all of these. And I come all the way up to here. So it's 20, 21, 22, 22, 22 again, 25, and 28. Those are my 20s. Then I'm ready for my 30s now. These are my 30s. 30, 30 again, 32, 35. That's it. Those are my 30s. Then I come into my 40s. So 40 and 41. 40 and 41. Then I come into my 50s. So my 50s here. That's 52, 54, 59. Then I come into my 60s. These are my 60s. 60, 65, 68. And there's also only 175. That's my stem and leaf. And I put in a key. I want to say key. All right, let's do the first example. 1. So at 1 line 5 means 15. Then maybe give another example. Means 15. I give any other example that maybe can maybe say 4/1 means 41. So you must always give a key when you have to construct a box and whisker plot. Always put a key. That's my key. It's always add a key to it when you have to draw one abstract. When they give you one, they give you a key. So when you draw one, you have to give them a key. So how many values are here? I'm going across here, so by 3 down. So it's 1, 2, 3, 4, 5, 6, 7, 8. 8 by 3, that's 24. That's 24 values here. 24 values. That's the n equals 24. N equals 24. All right, what does the one me to do? It says, state the advantage of using a stem and leaf to represent the data. State an advantage. The data is represented in a compact way. Data shown in a compact form. And another advantage is that stem values are not repeated. Stem values. That's another key. Stem values are not repeated. Right? So these stem values are not repeated at all. Right? Leaf values are repeated, but not the stem values. Determine the mode. Mode is the value that occurs most frequently. All right. So looking for any number that appeared multiple times, which is these twos, occur the most times. These twos, see? These twos occur the most times. That's 22 is the mode. 22 occurred 3 times. There are 3 22, so that's 22. 2 is the mode, 22. Don't put 2 in there, put 22. The mode is 22. Then I want the median. Median is the value in the middle. Since there are 24 values, divided half and half, 12 and 12. And so because there's an even number of values, is the average of the 12 and the 13. So the last value in the first half and the first value in the second half. So it's the average of the 12 and the 13th value. So this is equal to the 12 plus 13 value divided by 2. That's what Q2 is equal to. What is the 12th value? 13th value. You can actually see it in the table, because the table is in ascending order. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the 12th and the 13th value right here. Two of them are the same, means that the median is 30. So it's 30 plus 30 over 2. 30 plus 30 over 2 equals 30. But the data measured in. They tell us what data measured in. Let us give some values. You don't put the units on them. All right, let's give some values. Centimeters, inches, nothing. We don't know. Kilograms, we don't know. So give back some values. They don't want us to tell them the interquartile rate. So we need Q3 and we need Q1. We need Q3 and we need Q1. You can do it from the table again up here, so because as I said, your median is going to be a value right inside here. The average between these two. So I'm marking where the median will be. And so the bottom half of the data is this 12 values up here, so 12 values up here, so it's the bottom half of the data. And the 12 values down here, these are different color. The top half of the data. 12 values up here. This table is there, I can use the table. I don't go to this stem of data. So since there are 12 values up here, again, I'm going to have to divide it half and half. 12 divided half and half is 6 and 6. So the average of the 6th value and the 7th value is my median of the bottom half. So it's my sixth value and my seventh value. 1, 2, 3, 4, 5, 6. So this is my sixth value. All right, I'm averaging these two, my sixth and my seventh value in the bottom half. And in the top half, I'm also averaging, try it in the red, put it in the red. The values that I'm using, the sixth and the seventh value in my bottom half. Average them. And then the top half is the same thing. The 6 and the 7 value in the top half. 1, 2, 3, 4, 5, 6, and the 7 value. See there? I'm averaging these two to get my upper quartile. Since I laid out in the table, I can do that. 1, 2, 3, 4, 5. 1, 2, 3, 4. Good. So the bottom half average, clearly that's 53. This is my Q3. And up here, average of 21 and 22 clearly is 21.5. That is my Q1. Obvious. So it's 53, 21.5. My interquartile range, which is Q3 minus Q1 equals 53 minus 21.5. Or that out, that's the interquartile range. 53 minus 5. That's 31.5. All right, anything else? All right, so the one is probability. This is probability. So we'll do this sum of the probability. All right, let's look at 2050. So only 4 papers left, you know, might as well screenshot them. Since we're only doing the statistics part, data part, we're not doing the probability part. All right, let's see. Oh, so this one they used to set the paper without space to write. All right, bring it up over here. Trying to get up on screen. Page to write on over here. All right, so this is like a different question. Again, this is some group data. Question said there are 3 stoplights. This is probability. What is probability? So I skip over that. Find the probability. See? So coming down to part B. Part C also is probability. So leaving out part C. See? Draw a probability tree and determine the probability of something. Right? So we're only doing part B right here. Statistics part. It says use the data in the following table to estimate the mean. That's all you have to do. When estimating the mean from group data, you have to use the midpoint of the data as your scores. All right. So the formula for mean, remember, is the sum of frequency times the score by the number of values. But the score you're going to use is a midpoint score. I'm going to change this X and I'm going to call it M for midpoint. So we need a midpoint value. So what I'm going to do, I'm going to take this table and draw it over different. So I'm going to put my scores. In fact, I'm going to put in the midpoint values. I'm going to put in my midpoint values and my frequency. I'm going to put in a sum column. My sum column is F times my midpoint values. That's what to get my sum column right here. Remember, I know mean is sum over number of values. Sum is frequency times the score. But because the data is group, we have to use the midpoint values. So the midpoint, the frequency, we can put in the frequency there. That's 8, 4, 10, and 3. What's the midpoint of between 5 and 9? It's the average of 5 and 9, which is 7. 5 plus 9 over 2. 14 over 2, that's 7. So midpoint value for that first group is 7. For the second group, 10 to 14, same thing. 10 plus 14 over 2, that's 5 and 7, that's 12. That's 12. Yeah, 12. I can note, you know, these lower values going up by 5. See? So the midpoint values will go by 5 as well. Upper values are also going up by 5. See? These upper values are increasing by 5. So it means that the midpoint values will increase by 5. So once you calculate one of them, you can just keep increasing by 5. So next one is going to be 17. Next one is going to be 22. So what this means is that these are your scores. These are the midpoint values of your score. So you're assuming that all 8 values in the first group is 7. And all 4 values in the first group is 12, which is not necessarily true. And that's why we are actually estimating the mean. It's just an estimate of the mean that we are able to do. Why? Because we don't know the individual values. And because we don't know the individual values, the actual values, we use the mean to represent the group, which is not necessarily true. We're going to multiply these two to get the sum. So it's 8 values. Each of them is 7. So the sum of the 7 is 8 times 7, which is 56. Then there are 4 12s. 12 was used 4 times, approximately. That's 48 the add to. So 4 12s add to 48. 17 appeared 10 times. So the sum of the 17 is 10 times 17, which is 170. 22 appeared 3 times. 22 appeared 3 times. So that there are 66 that add to. Then we need the sum of those values. Sum of the sum. That value is what is coming up here. So we're adding up those values now. Adding up these. Alright, so that becomes 54 plus 48 plus 170 plus 66. That's 338. Sum of all the values. So the mean becomes the sum of all the values is 338 approximately divided by the number of values. What's the number of values? If I add up this frequency, you get the number of values out of these. That is your n. You add up these. What is that? 8 plus 4 is 12, plus 5 plus 10 is 12 and 3 is 15 and 10 is 25. So that's 25. 25 values. Right? So you do 25 on a year. So it's 338 divided by 25. 13.52 is the mean value of that. Approximately. The mean approximate. That question done. So it's the majority of this question was statistics. So one of the statistics. Maybe the next class, next time we meet. All right, exam is what? Exam is next week. Week after next. Week after next. All right, 2014. I want us to work through all these papers before the exam. All of them. All these papers. Work through all of them. Or give you the solutions. And tell me which ones you want me to explain. I want these papers to go work through. Yeah, but you are working out the exam. So you have to work them out now. No, after you do them, I explain it. That's not a problem. So, you know, and just look for the solution and look right there. Suppose we want to be efficient. Suppose I give it to you to do, and you do it and get it right. You look at my solutions. Why need me to explain it again? We do these questions multiple times already in all of them. I remember that every topic that we do the questions in the past papers. So we'll do that multiple times. I don't have a problem, I'll do it, you know, but I'm just saying to be efficient. To be efficient and have an efficient exercise. It's better if I only need to work the one that you have a problem with. So if it is a question and you know you understand it fully, then you don't have to work the one that again. You understand it fully. I will put it this way: the one that you get right, leave those for last. Good? Alright. So anyway, this one now is on, let's see this one now. All right, so another question here now. Oh, this is probability too, you know. This is probability. So this part of it is probability. So I'll leave that for the next time. See, that's the probability. All right, this is a sample space, what you call a sample space. So you have to fill it out. So we'll do that, all of that in the next class. It's a probability question. Down here also is probability. So all right, just the money here. That's the money. That's the diagram here. Well, if you understand it now, but I'll do it then. Right? I'm gonna start both things, go on, right? All right, let's go. This is it, right here. Question says the aptitude score obtained by 51 applicants. You know that there are 51 applicants. So since there's an odd number of values, you know that one of those values is the median. So you're going to go 25 from the top and 25 from the bottom, and the one in the middle is the median, right? And when you have 25 at the top and 25 at the bottom, 25 at the bottom also is an odd number. So one of those 25 is going to be Q1 as well. Which one is it? 13th one. But 25 is about 12 and 12, the one in the middle. You understand that? And the top half again, we have 25 on the top half. But at 25, it's about 12 and 12, the one in the middle. So the top half is the 13th one in the top half, gonna be your Q3. So a question like this, you don't have to calculate no median. You have to do no average, nothing. One of the values is the median, one of the values is the Q1, one of the values is the Q3. All right, let's look at it. It says find the median and the quartiles. See? Remember the median is a quartile. So the median is going to be the 26th value. If you don't remember that this 26th value, you can calculate it. It's half position of Q2 is half of n plus 1. And it's 51 plus 1, half of 52 is 26. She says 26. Even if you read it all, so look for the 26th value. So let's divide it half and half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Wow. It so happens that all of this up here is the first 25 values. So it means that this value is the 26th value. This one. That is Q2. And then it means that all of these down here now is your top half. This 25 values up here is the top half. See that? So we know the Q2 already, you know, it is 71. You see it? We're counting 12 from up here so now to find the 13th value. 12 and 12. Want the 13th value up here, so and 13th value down here. All right, the 13th value. You see the 13th value from here down here, so you can count it from this end to, you know, from the last one back in. So it's the 13th value from either end, from the left or from the right, right? So want the 13th value now for Q1. Let's mark it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the 13th value. Then from down here, so they want the 13th value again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the 13th value in the bottom half. So this value down here says Q3 is equal to 79. This value up here, so is Q1 is equal to 56. And in the exam, you can mark it up like this, and nothing wrong with that. And this value is Q2 is equal to 71. All right, so those are the quartiles and the median. And then I want you to do a box plot, box and whisker plot, right? So the lowest value is 31. So let's look at one. 31. The highest value is 96. 96. And the values in between are 56, 71, and 79. The box going over these values. The whisker going on to those. So that's what we're going to plot. All right, we're going to do a nice number line. So we can start at 30. I'm going up to 95. Can go by 10. You can go by 10, right? Yeah, we can go by 10. So we're going to start at 30 or so. 40, 50, 60, 70, 80, 90. That's my scale. Let's put on the figures now. So the lowest value is 31. 31 is just about here. That's the lowest value right there. At the end of the whisker. Then the first quartile is 56. So 55 would be about here, so 56 will be about right here. Good? That's the start of your box. The median value is 71. 71 is about maybe here. So let's put another box right here, another line for your box. Upper quartile is 79. 79 is about right there. So you put it right there. Then the end of the last whisker is at 96. So I put 100. We needed 100. So 100. So 96 would be around, right? So 95, 96 about it to the right of that. So you close up your box. And you join your whiskers. This one is negative skewed. See it? Over here is a longer. See it? Whisker longer and the box longer over this side. So it is negative skewed. I always ask you that, comment on the data. So I'm going to say it is negative skewed. But the whisker on the left is longer than the one on the right. And even the box on the left is larger than the box on the right. So this is negative skewed. Or less skewed, skewed to the left. Negative skewed. Done. So good? All right, 2030. All right, let's jump to it. Whoa. 2013. All right, 2013. Let's see. 2013. All right. So part A, that's a probability tree. So that part clearly is a statistics part A. A statistics probability question, probability theory question. So that is a part B that we're going to do. Down here, part B. Part B. All right, so let's see. All right, so the marks obtained by 30 students in an English exam are given. And give those 30 marks, right? It says state one advantage of using a stem and leaf diagram versus a box and whisker plot to display the data. State one advantage of using a stem and leaf diagram versus box and whisker plot to display the data. What do you think? One advantage of using a stem and leaf. But them say versus a box and whisker plot. You see the values. So you see the values in a compact form, right? Good. But if you do the box and whisker plot, you're not seeing the values. You only see the quartiles. And you see if it is negative skewed or positive skewed, we're not seeing the actual values. Good. So that's the answer you'll give them. Firstly, the stem and leaf make the data more compact. The stem values are not repeated, but you still can see the values, right? And then now the box and whisker plot, now you're not seeing the values. You only see the quartiles, the position of the quartiles. All right, it says construct the stem and leaf for this stuff. You need me to do it? It says construct the stem and leaf. You can do that? You don't have to do that. Let me do it. The second part of the question is supposed to construct the stem and leaf. May I see if I have to do it? Huh? May I ask you if we can go up and do it? Because it's the same as before, right? Is the data in ascending order? No, that's the only problem. Right, so let me do this one. What I want to do is mark off the data. Right? Mark off the data. So let me do this one. Let me do it. All right, I'm gonna do a stem and leaf diagram. Similar to the one that we did before. We'll start this one out. The data is not in the setting order. So you have to make sure that we don't miss out any data. So usually you put you underline them. I don't like to cross them out. But to underline them because if you cross it out, you need it again, you can't see it again, especially if you're using a pen, right? So let us see. So I'm going to put my stem. Look at the values. What are my tens values? The lowest one is the 40s, right? And it goes up to what? Up to 90s. Good. So it's 4, 5, 6, 7, 8, 9. So if it has some hundreds in it, you put 10 to it. Good. Now suppose it don't have anything in the 90s, for example. So it had nothing in the 90s. Or suppose it had nothing in the 70s. What would it be? If it had nothing in the 70s, for example, you just leave the line a blank. Don't put anything there. Still put a 7, but don't put no value in there. Means that there are no 70s. You understand? All right, let's continue. All right, so the lowest value is what? 40. 40. Next one is 41. I'm seeing right here. 41. Then I'm seeing a 45. 45. And anything else in the 40s? Nothing else in the 40s, right? Huh? All right, 50s now. See a 50 right here. Another 50. So 51, another 51. That's 2 51s. 1. And then 52s. I see a 53 right here. So a 53. Oh, so another 50 here now. So another 50 there. So the shift is over. There's another 50 right here. All right, 53s, 54s, 54, 55s. See a 56. See a 56 right here. 57, don't see any. 58. See a 58 right here. Oh, see another 56. Another 56 right here, so 56. Like when I'm scrolling the data like this, 56, You didn't make you waste time. 56. Over 57, about 58 now. So if I'm doing this in exam, I'm using a pencil now. 58 and the 59. All right, over 59. 60 now. Huh? Or if so that, what is it? Another 58. 58. All right, thanks. 58. All right, ready now. 60s now. The lowest I see so far is 63. See it right here. 63. And the 64s, no, it's another 63 here. Another 63. 64s. 65. I said 266. One on the top line, one on the bottom line. 66. 6 and 6. 6 and 6. 67. 68. See a 69 right here. 69. 70 now. All right, I don't see no 70, but I see a 72. See a 72 right here. 72, 73, I see a 74. 74 down here, so. Then there's a 75 and another 75. Two of them, 5 and 5. See a 76. 76. Any other 70s? We won't see any other 70. But I see an 80, right? On the top line is an 80. 80. I see an 81. It's an 81 right here. 81. 82. I see an 83. 83. 83. 84. No, 84. 85. Say 85. 85. 86. We don't see no 86. 87. Another 8 is there. 89. 89. Where is it? Where is it? 89. Yes, there. 89. There are no 90s. I start at 92 is the lowest one. 92. 94. 99. What a wicked thing. But that's the box. You have to put in a key. I always remember to put in a key. So I'm going to write key. I'm going to write 490 means 40. I'm going to put another one. 9/2 means 92. All right? Give them that. All right, so we draw the box and we say, then we want the median now. So now that we have it in ascending order, how many values are here again? 30. So since it's 30, we divide it 15, 15 first. And then it's the average of the 15th and the 16th one, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, these two. Give it a median. So the median is 66. So that? This one and this one. That's the 15th and the 16th value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 value. So the median is 66. 66 is the median. 66. 66. Then I want the semi-interquartile range. So for the semi-interquartile range is the interquartile range divided by 2. So we need 2 quartiles. Remember, because the median is the average of these 2 values. Watch this now. Because the median is the average of these 2 values, the median is in between them. So those 2 values are a part of the bottom half and the top half. You understand? Good. So these are a part of the bottom half and the top half. So the bottom half includes these. That is the top half, bottom half. And the top half, I'm going to draw it in green. Top half is these. There are 15 values there. So since there are 15 values there, one of them is the mean at the bottom half, and one of them is the mean at the top half. So you want the seventh value, don't it? Seventh at the top and the seventh at the bottom, right? Seventh value. 1, 2, 3, 4, 5, 6, 7. So this becomes Q1, 7 value down here. And you can come with 7 more. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. No, not the 7 value, the 8 value. 7 and 7 is 14. So the 8 value I want. The 8 value, not the 7 value. 1, 2, 3, 4, 5, 6, 7. The 8 value I want. They're going to have 7 below it and 7 above it. 1, 2, 3, 4, 5, 6, 7. So the 8 value I want. 1, 2, 3, 4, 5, 6, 7 is the 8 value I want. So those are my quartiles. All right, so I can write it over here. My Q3 is 80. My Q1 is 53. So my interquartile range is the difference between them. 80 minus 53 is how much? 27. 27. So my semi-interquartile range is what the question wanted. 27 over 2. 27 over 2. That's what 13.5. 13.5 is a semi-interquartile range. That's what this question. It says 2 students are chosen at random from the class. Determine probability that both students scored less than a score of 50. 2 students are randomly chosen from the class. Determine the probability that both scored less than 50. All right, it's 2 of them I want. And they must score less than 50. So the first thing you want to know, I'm going to approach this now. Normally the question will say 1 student is chosen, but no 1 on 1, it's 2. Right? So what you have to do, you want to choose a first one and a second one. So that's a probability question, one of the probability yet. So the and situation. You want, like, you take out 1 first. First one is, like, you take out the first one to score less than 50. And then you see how much is left. And then you take out the second one to score less than 50. So the first one who score less than 50, how many of them score less than 50? That's the first thing we want. That are these down here. So scored less than 50. Less than 50. That's these, you know. Right? That's all. 3 of them, right? So how many students are there now? 30, don't it? So the first one who scored less than 50 would be 3 out of 30. And then you also want 2 out of the 29 you left. That is left. Those are your 2 students. So the first student that you draw is out of 30. Only 3 of them score less than 50 out of the 30. When you take out the one, 29 students they have left. Out of 22 of them alone in there would have scored less than the 50. So the probability becomes 6 over whatever that is. 30 times 299. 30 times 2. 30 times 29. 870. That's the probability of getting 2 students who score less than 50. Not 1, 2. 870. So you want the first one and, because this is and you multiply the probability. And you also want the second one. Huh? That's what it's reduced to. All right. 840 divided by 6. Yeah, but the 6 can go to the 30, right? That's right. It's 5 times 29. So it's 1 over 145. 1 over 1 out of 145 chance. 2 students who score less than 2 students, probability that two students are chosen. I want both of them score less than 50. So the first one I take out, probability of finding the first one, straight out of 30, didn't come out already. And you want the next one to come out to also score less than, is only 2 left out of the 29. So you multiply them because you want the and situation. That's it. And you have to multiply the probability. All right. Then we'll come to 2012. Last we're doing for the 9th. So you see, we would have completed all of the papers on this topic. Statistics, right? So more than likely you get a question similar to one of these. So we're going to do the probability questions in the next class. Probability. All right, so let's see. So another question are statistics though. Survey is carried out at all will be 25% of households surveyed, 10% on laptop. This question is a CSEC like question. You can basically draw a Venn diagram for that one and do it. Show you. You know the I can show that one. But that one is like a probability. It's like a Venn diagram that I'm going to show you what happened that. Some of these statistics question can do them using Venn diagram. Use Venn diagram to do them. You can use a Venn diagram to show you the information and to represent information. This question says a survey is carried out in a town. I reveal that 25% of households, 25% of the households so they own laptops. So laptops, 25%, that's 25 out of 100. 70% own desktop computer. Let's keep for desktop. 70%. Right. In addition, it was found that 12% own both. 12% own both. So both. That's L intersect D. That's why we buy both. It's 12%. 12%. So I can draw a Venn diagram to represent this information. Though. Remember, it's 100%, so everything must up to 100%. So I draw a set for the laptop, a set for the computer, right? For the desktop. Now 12 is in the intersection. I tell you that already. On both, so I know 12 is in here. We're working in percentages, right? The laptop is 25. So everything in here must add up to 25. So right here is 13. Over here, everything must add up to 25, must add up to 70. 70 minus 12 is minus 10 plus 60 minus 2 more is 58. And they add up these, I know how much is out here. But everything must add up to 100%. That's 25 and 58. That's 83. Subtract that from 100. Get 17. So you have 17% who don't own any. That's a Venn diagram that will help you answer anything. It says if a sample of household from the town is selected at random, determine the proportion in percentage, right? That owns neither laptop nor computer. Neither nor. 17, that one. 17%. 17%. Neither laptop nor computer. There's 17 on there, so you will have 4 marks for that. Oh. Yeah, that's it. A bag contains 4 red marbles, 5 black marbles, and 3 blue marbles. 3 marbles are drawn at random without replacement for the bag. Find a probability that the marbles drawn are all of the same color. So we're going to do this in the next class. All of the same color. So if you want them all to be the same color, and 3 marbles is either they're gonna get 3 red, or you're gonna get 3 black, 3 black, and let's use alpha blue, or you're gonna get 3 blue, or you get 3 black, or you get 3 red. How many marbles in the bag now? 10, right? You get the first red. So this probability to get a red and a red and a red, and you multiply or you add. And you multiply or you add. So you want a red and then a red and then a red. The first red, them say without replacement, right? It says without replacement, meaning that when they take out the marble, they don't put them back in the bag. So the total number of marbles is reduced with each removal, right? So we take out the first red is 4 out of 10 times. The second red is going to be 3 out of 9. Third red is going to be 2 out of 8. See that? That's the probability of getting a red and a red and a red. Or, meaning you're going to add the probability of getting a blue and a blue and a blue. If the first one is a blue, that's 3 out of 10 times. The second one is a blue, that's 2 out of 9, because there's no replacement. The third one is a blue, that's going to be 1 out of 8. 1 out of 8. Then you want to get 3 blue. So the same probability as the 3 black. Same as the 3 black, because the same 3 black in there as the 3 blue. So it's plus 3 out of 10 times 2 out of 9 times 1 out of 8. Work that out and that is that. So you get 3 red, or add, or you add, you get 3 blue, multiply them, or you get 3 black or 3 blue. Huh? Is 2 over 9. That's 2 over 9. Watch this last one now. To get exactly 1 red, you want to have 1 red alone. Watch this now. It's gonna have 1 red alone, right? So you're gonna do this now. Is either gonna be the first one is gonna be a red. You watch me? Second one is not a red, and the third one is not a red. Or the first one is not a red, the second one is a red, and the third one is not a red. Or the first one is not a red, the second one is not a red, but the third one is a red. Those are the possibilities. So in this case, because we're doing red, not red, you really have 4 reds. You really have 4 reds and 6 not reds. That's what you have in the back. Don't it? So ready now. First one, first draw is 4 out of 10, don't it? I must say now replace it now. 4 out of 10. Second one must not be a red. So you want 6 out of 9. The third one must not be a red. So you want 5 out of 8. See that? I remember not replacing the board, replacing them. Plus, other possibilities that you don't get a red first. That's 6 out of 10. Times. You want a red now. 4 red are going in there now. So you're going to get 4 out of 9. Times. You're gonna have you take out the one that is not red already. You take out a red. So you're gonna have, you don't want it, so in terms of not red now, you're gonna have 5 not red. 5 not read out of 8. See that? I took out 1 read already. I took out 1 not read already. There are 5 not read out of 8. Plus not read is 6 out of 10. Another not read is 5 out of 9. Then a red is 4 out of 8. Work out this, and that is the answer. All right, so now I'll do the setting about this question. Never really have any statistics like question. No? The straight statistics question is every part of it is statistics. Probability really. Every part of it is probability, not statistics, probability. Probability of hiring a taxi from a garage A. I want a probability 3 for this question a bit. Illustrate, see there? Probability by showing a tree diagram, probability 3. Yeah? Once you see the set all like that's a probability 3. We want to do this in another class. I don't want to do many other things. Let's focus on what I want to do. How about the probability? We do about the probability questions in another class. But you see that we might need 2 classes to do it because most of the questions are probability, right? So I might need 2 classes to do. That is it for today.